This is I'll teach you part 2 of this backlight inverter. So basically, previous one my tools that was fluorescent light or CFL compact fluorescent light video. I am running this CFL lamp with this backlight. I am say in this video I made a trial reversing in this board and explain how it. So basically, this video I upload 4 months. So I reverse engineering done in first month, but I cannot upload due to there are I do not make a video, but right now I made a video. So there are so that's it. So there are right in 3 parts. First, all this time is adjustment point is it I keep in number 6. But right now I forget to attach them, but I later tell. First, positive. There is positive which is connected to a positive is unknown fusible resistance, which is then feeding to the circuit, and before it feeding there are then under modified 16 volt capacitor to smooth this voltage, and there are 1 volt capacitor which is not input of the jet positive to positive, negative to negative, 220 modified 25 volt. It is stable the main voltage, then it's diffused, then it's restable, and then those are circuit. So this there are ground is common. There ground is common. So positive dose, the first transistor which is enabled by IC pin number 12, and this IC is mystery. This transistor is mystery transistor. Then there are these transistor both collector terminals, which then it can IC then 11 pin number 11 can turn on this transistor which can turn a collector to pin 9 of IC to turn on the IC. So IC pin number this other transistor. This transistor base is normally pulled 47 ohm resistor. So once it's then that turn on, it is voltage collector, and then it's feed to MOSFET. But MOSFET discharge they require a 10 kilo ohm resistor to discharge MOSFET daily. But there are one diode, another diode which is missing. There are all the places, but diode is missing. This diode is for that also clamp the voltage to 12 volt. Now in some reason input voltage is too high, it cannot till the MOSFET dead, or it is also discharged quickly. So then this MOSFET can turn on, and source, this MOSFET source is connected to a board MOSFET source. Both MOSFET is connected positive. Source is positive, they are P channel MOSFET, which is voltage turned to drain, then it's transformers, and then this transformer is coupling with capacitor, which this capacitor has a number network or series with capacitors. Which can coupling the voltage, and then once its voltage generates there, it's turning to its both outputs. Other transformer is similar way. So other MOSFET is drain is to a transformer, and then it's to a capacitor coupled to ground. There are unknown capacitor, and there are MOSFET sources connected to the positive line with 10 kilo ohm to gate, which is pull up, and there is another which is also pull up, but this is to pull down by this IC to turn on, which can pull down by this transistor. And first, and they are ground. So 8 or 7 is ground. There are 7 pin number 6 adjustable signal. 5 is pulled up by 80 ohm resistor, and 4 is pulled up by unknown valid capacitor. Pin number 3 is also pulled up by one 10 kilo ohm and 1 10 kilo ohm voltage divider to maintain input feedback. This feedback is smoothed by there are 1 capacitor which is unknown value, and there are 39 kilo ohm cross this resistor, and there is capacitor which can stable or smooth the voltage which can pass through this resistor. And this pin number 8, pin number 2 is also 12 kilo ohm to pull down, which is at internal temperature input temperature setting, and pin number 1 is 47 kilo ohm to pull down, and this ground is connected to the determined ground. Now it's play side. So always can output these two jacks, transformer secondary outputs with these two jacks, but there are one more jack which is this time there are which is two lamp in connected series with one single transformer, same as other. Two transformers, one transformer connect two CCFL lamp in series. But same time it is little bit more subtly a series which can knows IC it's enable or not. So there are jack, which jack is also series with two lamps plus this one feedback circuit is series. So this lamp, this is a pin number 2 connected to the platter terminal of the first transistor and second transistor platter. Both transistors base are connected pin number 1 and both transistor base is pulled down by 80 ohm and 80 ohm to 470 ohm. I mean 80 ohm and 1 kilo ohm and 470 ohm for bottom section. That means 40 ohm and that means because these two resistors parallel, and this means 400 ohm resistor is there, and then it's moved to the transistor base voltage by this unknown value capacitor, and this is unknown value capacitor. I mean transistor which can voltage dip to the pin number 1. I mean this feedback point which is both are common to 10 ohm 470 ohm resistor which is limit the voltage over the IC, and then into the IC pin number 15 which is an internal temperature. Same as this, but this time this transistor ammeter is connected, this transistor ammeter as well as there, and this transistor ammeter and this transistor ammeter and this transistor, this IC, I mean 470 kilo ohm of IC pin number 15 is also common to these 4 points. So it's 10. There are 4 signals. The top side signal is for voltage overload or underload protection circuit. Because this time, if voltage is dropped of this jack, which means these 2 pins, but that clamp the voltage because there are zener diode which is and 1 kilo ohm resistor to limit the voltage, and once its voltage is dropped down, there are limit point is also dropped down, which can slowly trigger this transistor, which can slowly convert voltage collector to ammeter and give to IC low voltage or I status. So that no ICs, there's a feedback is working or not. Pin number 14. Pin number 13 is not belong to the pin number 12, which is this transistor base terminal to check the enable to known IC transistor is active or not. So there are 2 capacitor and 2 unknown value capacitor and 2 10 kilo ohm resistors with parallel with 5 kilo ohm resistance and 2 unknown value capacitors connect to the base of the transistor and to IC pin number 13 to internally feedback of IC. So this internally IC. So this IC generates a PWM signal which is in pin number 10 and pin number 9, pin number 11 and 10 is for PWM output and pin number 12 for enable. So basically in off mode, when this input is I, it goes to IC and IC can turn off the internal circuit. So IC cannot generate the on signal with logic 5 volt there. So that's why this transistor not under voltage. Negative voltage collector to ammeter to turn on this circuit. IC can control this on off this circuit and these two PWM, and then it's use a MOSFET to drive this transformer. So let me be. So there's a backlight. It's backlight. Although this backlight, this type of plastic is broken without. I see there are transformers. As you know, there are high voltage transformer which is contain 5 step down side sections and 1 is main section. So meaning 5 kilovolt each have 1000 turn of wire wound each lap. So there's 5 lap, meaning 5000 volt secondary output, and this is our primary lap, which is lap number 6, which is contain I turn, and this is 2 MOSFET. I would search a MOSFET data sheet, which is these MOSFET let me XR4660. These MOSFETs are two MOSFETs. So basically there is not one MOSFET. There are two MOSFETs in single package. So both are parallel to protect overheat. So that's why it's those 6-pin IC, but there right now is 8-pin because there are two is gate, two drain, two source, and two is not NC, which means no connection, and there is tiny little components is. And this is a small little circuit diagram of this backlight inverter chart. Pause.